Good day, everybody. Thank you all for joining this webinar today. Today we will be talking about the system configuration utility for PRAESENSA, which is a design tool that helps consultants and also system integrators to design and specify PRAESENSA systems. So today's webinar is being recorded, so afterwards you can review the webinar if you want to. Questions, please keep them until the end of the presentation. Afterwards, there will be a Q&A session and we will answer them. You can post your question into the chat option, which you have on the right bottom corner of your WebEx interface. This is what it looks like. Please make sure that if you post the question that you send it to all panelists so that myself, as also my colleague, can view them. So today myself will be presenting Maarten Winks, a Regional Marketing Manager in EMEA for Public Address and Voice Alarm, and I will be today here accompanied by my colleague Vitas, who is Application Engineer for Public Address and Voice Alarm. So what are the objectives of today? We would like to show you our system configuration utility for PRAESENSA, and we would like to explain you how this helps consultants during system planning and design and specifications. Before we do, here is a small overview of the topics. So we will have a short introduction. We will also look a bit at the PRAESENSA system in glance. There is a short introduction movie for those who are not familiar with the system yet. Then we will look at the purpose of this system configuration tool for PRAESENSA, and Vitas will show us a demonstration on what it actually looks like, how you operate and use it, and also what new features are coming with this tool. And then afterwards, we will have the Q&A. So let me first allow me to show you a short introduction of the PRAESENSA system.
Hello, my name is Maarten Winks, working at Bosch Building Technologies. Today I would like to talk to you about PRAESENSA, the Bosch Public Address and Voice Alarm System. So PRAESENSA is a fully IP-based public address and voice alarm system. And I would like to show you a little bit what the system looks like so you get a better understanding on what hardware components we have that altogether make the system. This is the PRAESENSA system, which comprises various modules which make the family. So what we see here is the system controller, which is responsible for routing the audio towards the amplifiers. Here we have the amplifier, which comes in a 4-channel or an 8-channel version. They provide 600 watts with dynamic power distribution, so you only use the power that you actually need in the zones. And here on the bottom is the multifunction power supply, which is powering the rest of the system through mains as also normal battery backup. System also comes with call stations. So this is the desktop call station. We also have a wall-mounted version, and it is featured with a touchscreen display. So the operator actually is guided by, for instance, making a call. The touchscreen display is giving feedback when the operator needs to speak. Whether the call is delivered successfully, the feedback is also provided. So if you want to have a better understanding, have a look at the complete portfolio, but these are some of the components that are building the PRAESENSA family. So now we have seen what the system looks like. I would talk to you a little bit about the core elements that are making the features of this system. So there are 5 pillars that are basically defining the sales value proposition. So the first one is that the system is fully IP and it is also secure IP. The second one is that it is using an effective power utilization to save power and utilize the power as good as possible in your system. The third one is high system availability, because we're also talking about safety systems. We always need to have a constant working system. And the fourth one is the user experience. So PRAESENSA is not only designed from a technical point of view, but it has also incorporated a lot of user feedback to make sure you have a system that is nice to work with and also appreciated by users. The fifth one of the sales value proposition is fully featured as a standard, which means the complete Presensa family is basically one portfolio that allows you to build a fully EN54 certified PA voice alarm solution without adding additional components outside the portfolio. So the first one, secure IP, I would like to show a little bit what does that mean for Presensa. We will have a short glance at this short introduction movie to get a better understanding.
Every device in a Presensa installation is fully interconnected via Omnio, the advanced media networking architecture. This enables digital audio communication and complete system control across the entire IP network. Omnio is a flexible, scalable, and secure architecture which is based on proven technologies and open standards. Omnio supports audio encryption and real-time authentication across the network for added protection against eavesdropping and hacking. This professional-grade media networking architecture allows Presensa to take full advantage of the benefits of secure IP. That means greater scalability for centralized and decentralized systems and easier installation and better audio quality than any other public address and voice alarm system available today.
So now we have seen what fully IP-based and secure IP-based actually means for Presensa. Next topic I would like to introduce is the effective power utilization. So we know from experience that often there is a mismatch between the installed system power and the actually used system power, and we tried with Presensa to bring those figures as close as possible together so we are utilizing the system power to the maximum. Also there I have a small animation to show you how that works.
Presensa adapts intelligently to connected loudspeaker loads, dividing the available output power across all channels to a maximum of 600 watts. Innovative load sensing allows Presensa to maximize efficiency, which means less surplus power, less supply power, and fewer amplifiers are needed to cover the speaker's power demand. Each Presensa amplifier includes a spare amplifier channel, which automatically takes over in the case of a failing channel. Compared with traditional systems, Presensa uses around half the amount of amplifier power to do the same job. This reduces rack space, heat loss, and fewer batteries are required.
So since we are talking about a safety system, high availability is one of the things that are extremely important. So also here with Presensa, from the core design of the system inside out, we already considered in the first system design that high availability should be part of the concept. So we have 5 different features inside the system that is helping you to avoid any single point of failure in the single system to make sure that it is always working properly. Also there we have a small animation to show to you how is that reflected in Presensa.
Presensa gives you robust and comprehensive security with a design created to ensure no single point of failure. All devices and network connections on the system are constantly supervised, as are critical signal paths and functions. In the case of a failing amplifier channel, there is an integrated additional spare amplifier channel which will automatically take over. Each amplifier channel has 2 loudspeaker outputs which are separately supervised and protected, ensuring uninterrupted coverage in all areas. Every system device uses dual Ethernet ports and will recover automatically should a network link break. To maximize system availability, each Presensa device has twin power converters. These, along with the battery backup facilities, make the entire system immune to mains failures.
So now we have seen more the technical side of the system. So we have seen the IP infrastructure, we have seen the power utilization, and we talked about high availability of the system, but there is also somebody using the system. So there with Presensa, we took a clear decision that we wanted to have a user-centric design, and for that we interviewed customers and we designed the system together with them.
With started in our project with a context of use analysis. This is the basics where you really start the whole user experience.
So we made interviews in several countries in different verticals with real users. Users were receptionists in shopping malls or hotels, but also professional announcers in airports and convention centers. We were surprised that we hardly found satisfied users.
With this insight, we found that this is a very important thing that we want to improve now, that we make our devices so easy and so intuitive that everybody approaching the device and also using it maybe only once a year still feels secure and knows how to use it.
So we came up with a couple of proposals, prototypes, hardware prototypes as well as software prototypes, and again went out to the users to let them test these devices. Controlling a PA system is a challenging task for the users. They might control the system in applications where they have 50, maybe 100 zones. So keeping the overview is key for the usability. After several iterations, we came to a solution which made our customers really happy.
So now we have seen how the user design was part of the design process of PRAESENSA, and we've seen how, for instance, making a call is now optimized through the feedback in the call station, which was inspired by what two users were telling us. But we didn't really stop there. We also want to make use of the PA system in a modern fashion. So one of the things that we, for instance, have done, we are introducing a mobile client which can connect to the PA system and allows, for instance, as you see here in this picture, that a retail owner could make its own background music, create their own ambience for his customers, maybe play some commercial messages or do voice announcements either through voice or maybe make some messages through text-to-speech. So a very modern approach towards usage of a PA system. So now looking at when we launched PRAESENSA, so we had different markets in front of us, target applications. So here on the left side, we see target applications which are combining background music with announcements. Here we have more the area where you have the announcements only. And if you look at the segments here, going from small to large, we have an entry level, which is basically compact and easy systems, the smaller sized offices, education, some retail. We have here in the center, we have the mainstream applications, so usually a bit larger building, like an office building or a hotel, education facilities. Here on the left side, we have clearly the ambience and experience kind of application. So like cruise ships, shopping malls, fashion centers, casinos, where the entertainment element is important. And here on the right-hand side, we have the larger systems, like in the transportation vertical. We're talking about airports, we're talking about railway applications, but also power plants, oil and gas. And if you see then where the PRAESENSA portfolio sits, so it's from the mid-range to the large range, where we are really covering from applications where you need to have quality background music up to applications where you care about the quality announcements being made.
Okay, thank you all. I understood the movie was jittering a little bit. Apologies for that. But I hope that the story was understood. So this is a short overview on what a PRAESENSA system looks like, how it is connected. So it is a fully IP-based system, as already shown in the movie. So here you see an IP ring connection, which is actually connecting all the PRAESENSA elements with each other. So in this IP ring, we are actually communicating and controlling audio. The protocol which we are using for this is called Omnio. This is an encrypted combination of audio control and Dante audio streams with an encryption layer on top. This is a very secure way of communication and also delivering a high audio quality. So in the meantime, PRAESENSA also is able to work in let's say, a multi-system approach. So what you see here is, for instance, the example of a railway station. So imagine you have each of the different stations. Each of the different stations would have its own system. Let's call it a subsystem, which can be controlled on a master system level. So we can make from a central control room emergency announcements into the various subsystems. We can also enable communication between the different subsystems. So this is now the example of different stations, but you can imagine if you have a larger complex, larger building with different floors, you might also want to make a split up in the system and segment the system. Or in an airport maybe where you have different areas, this could be a good solution. So coming back to the tool, so we all know if we start with a project, we start with a project evaluation, we start with the planning, and then at some point we come to design and specification. So when it comes to design and specification, it's very handy if you can have a tool where you can input data that is coming out of your project evaluation and planning, and which is generating for you the necessary information that you need to design and specify. So this is what we will be talking about today and what Vitas will show you. Let me first show you where this tool can be found. So it's on the Bosch webpage. If I go here, let's hope that it opens the Bosch webpage. So you're here now on the public address page on boschsecuritysystems.com. So here you can find a lot of information about PRAESENSA, and here in the top you see consultant resources and product catalog. So if I click on this, you will see the consultant resources part where you can download the tool. Now I hope that this was also shared. Not sure. Okay. So Vitas, if you don't mind, I would give the word to you so you can do a short demonstration of the tool.
Hello, good morning. I hope you can hear me. And let me now share my screen.
Yeah, I just saw the comment that you could not see the download location. I will afterwards show it to you once more.
So I hope you can see it. So
yes,
here's what appears when you access that system configuration utility. Of course, yeah, the legal part you have to just accept the disclaimer, and then when you do that, then you get to a description about that tool. It provides you brief information, what is needed from the user, what input is needed, and then what output the user will get. So if you are interested, you can read it through it, but in general way, all what you have to do is to provide a list with the loudspeaker lines. The purpose of the PRAESENSA system is to drive loudspeaker circuits and to feed different audio signals at different moments to different destinations. So usually a planner, a designer possesses such a list of loudspeaker lines, and that list must contain unique ID of each speaker line and also the power load for each speaker line. So if the user does not have it, then such tool should be and can be created. There is a certain regulation, certain condition how that list must be provided. It has to be simple text file where entries must be separated by delimiters. It does not matter if the delimiter is comma or colon or semicolon. So the tool recognizes delimiters and then accordingly sorts that data input. So if you want more information, you can scroll down and you see there are several examples how to create such lists. Also, if you are still in doubt, you can simply use a provided comma-separated value file. You can download it directly by clicking that link in the description of the tool, and open it in the usually in the Microsoft Excel. And then in the Excel, you see now a few entries. You could provide here line ID. You could specify if the line is a part of A and B pair, and then you could specify the power load. So basically, you need to fill three fields for each speaker line. If it is not A-B line, you simply specify line ID, then bypass keep second entry empty, and the third entry would be load. If the line is part of an A-B pair, then you specify line ID, specify is it A or B part of that pair, and then a load of that physical line, and so on. So this is how you fill it in. It doesn't matter how many lines you've got. When you are ready, you simply save it, close it, and then you can use that list in the tool. So now I'm switching to the next step in the configuration utility, where this all data must be provided. So the first thing to decide is if it is default 100-volt system, or in some rare cases you might decide you want to use 70-volt system. So here's a possibility for you to change between those two parameters, and then go to the next parameter. In many cases, project specifications, also common sense and engineering correctness requires that you leave some reserve for amplifier power capacity utilization. So let's say for cable losses and for maybe for eventual future expansions, you want to leave, let's say, 10, 20 or more % of amplifier capacity not used. That means later on, some speaker lines could be, for example, grown up with additional speakers. So that's a typical practice in the real life applications, when there is a running system and suddenly some area is modified, or the building facility has been remodeled, and the need of additional speakers is occurring. So you have to add more speakers. You simply connect additional cable to existing speaker line, add more speakers. That's how normally the speaker lines grow. So that means you have to be prepared for that. So let's say I will specify here 20% reserve. So those two values are correlated. So either you specify absolute values in watts, or you specify just percentage, how much of power capacity you have to spare, have to keep ready for a future use. Then the last step is to upload that speaker line list which the user has prepared. So when clicking on upload, the user can browse to that comma-separated value file. I've got here one file which I would use. So just for you to show, the file itself looks like this. So there's a ID loop 1, then comma, then space, there's an empty value, then another comma, and then the power load of that line. And I've got total list of 46 lines, so some pretty normal typical application example. So this is what I'm choosing here. When I select and click open, the tool analyzes that list already in the background and gives a summary to the user. So first of all, it specifies, it shows, it tells the user that 100 volt, a nominal voltage has been selected, the power load and reserve, two correlating values is 480 watts or 20% of the power capacity has been put into reserve. It specifies the CSV file name, and also it returns the count of circuits which tool has found in that provided list. If it finds some records or some entries which are not recognizable, not suitable for import, it simply discards those records and also gives a list or a number of the discarded records. Here, if you move your mouse pointer over the I sign, you see that empty records, records without specified line IDs, or without specified loads, or with 0 loads, those would be discarded. You see now one discarded record has been indicated here. The explanation to that is that in this list, there is one last line which is empty. This is a typical comma-separated value list which gets generated by an Excel sheet. So if you export an Excel list, an Excel table into a comma-separated value list, it additionally adds one empty line which has been here detected and discarded. So don't get surprised when you get this one entry here. So if you are fine with this confirmation, then you click and then you get your results. So your results are represented in the following way. It allows to specify the date. Normally by default it chooses the date of today, which can be modified for whatever documentation purposes. Then project name can be modified. Then it also provides first the list of speaker lines which has been submitted for analysis and for processing. So you see now 46 loops, each with the specified load, gives you the summary, total 46 loops with a total load of more than 6,000 watts. And then it returns after that already the optimized schedule, which contains clusters. You know that in PRAESENSA system, the amplifiers are built into clusters based on the possibility to be powered from a power supply unit. So then it says which cluster number, amplifier number, and then specifies either 4 or 8 channels, and the loop ID which has been assigned by the tool to that specific channel. So you could see now that the amplifier in the cluster 1, amplifier 1 channel 1 has been assigned loop 11, and so on. So all this information is provided. Then in the bottom row you see always the summary of the current cluster. You scroll down through all the clusters, all the amplifiers. You could see the summary for each cluster, for each amplifier, and then at the very end, the user can also see the summary of the total processing. That means that the total assigned channel count was 46. That's the number of loops. Installed channel count means that how many really amplifier channels would have been used, or how many amplifier channels are present in the current set of amplifiers. Then it provides you some statistics. It shows you how efficient that tool has assigned the speaker lines. So channel utilization was 82%. And then installed power utilization 74%. But it gives you this statistics based on the total power, but we should not forget what we have left 20% of the power reserve. So that means that we have to compare this installed power utilization with 80% against 80% of the total available power which was used. So you see now that total available power is where the reserve has been taken into account. So the available power utilization was 93%, so pretty good efficiency here. Then the main result of this tool is that it generates a bill of material, a list of equipment, which then can be used further to place an order, if to create a project specification and so on. So all the components of PRAESENSA system are present in this list. Those components which have been specified by the calculation have been already pre-selected. So in addition to that, user can modify the number of any additional components which would be needed, which user deems necessary. So the number of additional components here can be modified in the grade fields, and then after this modification, the list can be exported. So and can be used then in whatever way user deems necessary. When the export button is clicked, the bill of material, also comma separated value file, automatically is downloaded, generated and downloaded. Then the user can open that list, and then in a Microsoft Excel, for example, and then could use this simple raw data in whichever way the user deems it necessary. It contains the product ID, product name, description, and then the quantities. So this is also a pretty useful feature, which might be implemented. So in addition to this bill of material, the tool provides you the worst case scenario power estimation, power consumption estimation. So it gives a list, it gives a table of how much battery capacity would be needed for each cluster at the given conditions, how much current it would use, how much also mains current, and how much power for each cluster would be needed. So that would allow the planner, the designer, to also to give parameters for power supply specification. So in addition to that, also the designer can consult any of the data sheets of the PRAESENSA system. It has been made pretty easily accessible. So if I want to investigate what kind of item is multifunction power supply, I can click and then I get directly the data sheet of that device. So then if I want to have a printed report of all this these configuration calculation results, I can choose I can click on print, then I get the choice of what content would be printed. So depending on my needs, I can choose if I want to get the printout of submitted schedule, optimized schedule, summaries, bill of materials, whatever. And in addition to that, also technical specification. Just for demonstration, I choose all of them. And then when I click confirm, I get a preview. So here I get my printout preview, formatted, usable in a readable, easily readable and accessible format. So the total of 17 pages are present in this specific case, and then I can go through all pages, see now each one page represents a cluster, so I can click through, scroll through all pages, see all the results here, all the equipment list, power parameters, power calculation, and after that I also get this technical specification. So here I get technical specification of each device, of each PRAESENSA component, which is present in the list with the quantity more than 0. So if at least one item of the equipment is present, then the technical specification automatically includes that item. So all this information can be easily saved, sent to per email, or simply printed out. After that, it can be printed either as a PDF or on a paper and so on. So that is basically it at this moment. And then we do not stay steady. So we collected some feedback from from the users, and then we are improving the tool, and we expect that approximately in 1 month we will have we will release an update. We'll publish an updated version of that tool, which will include additional modifications and additional elements of the PRAESENSA system. So let me go back to the presentation. Martin, could you please?
Yeah, thank you, Vitas, for the demonstration. So let me share now my screen again. Yeah, maybe first before can you see my screen, Vitas?
Yes.
Okay, good. Then before we dive into the rest, maybe show you quickly where you can download it, because that went wrong just a minute ago. So you can now see it, the web page. So this is boschsecurity.com. There is public address system. So here you can find all the information about PRAESENSA and also the rest of the portfolio. And here in the top, you find a menu, consultant resources and product catalog. So if you click on that one, yeah, go to the consultant resources, then it will open a a page with various informations, the EASE files, the BIM files, data sheets, A&E specifications. And here is actually the design tool that Vitas has just explained to you. So the PRAESENSA system configuration utility, if you click on that one, then you're actually ending up with the web page that Vitas has just shown you. Okay. Vitas, then there were a few modifications and new features, right, which you maybe want to talk about?
Yes, yeah. So as you know, PRAESENSA system grows, and there are a couple of, we can call it major additions to the system family. It's a small controller and control interface model. Then also the Pixie core for interfacing PRAESENSA with the Presidio, with existing Presidio installations, and also some extra accessories have been added to the PRAESENSA system. So here the complete list, but will be provided in this bill of material table, where the user, for the user convenience, would be able to specify if as I said, if at least one item of each device is present in the table, then the quantity is at least one. Then the technical specifications would include also that device as well. So that would be then candid tool for designers, for system specifiers. Also, we have received a few remarks about the tool performance, and one of the things was that in certain combinations of speaker line loads, sometimes the result is not completely optimal. And that has been addressed. Now we believe that now the optimization has been improved, and it will be performing now as expected, as you would see. Yeah. So also a few typos have been corrected as well. Not sure now if I can remember which ones, but just few glitches and few typos have been corrected, and also the efficiency has been improved. That's what has been done with the current version of the tool. Yeah, if Martin, if we go to the next slide. Yeah. Also, you also are aware about the power calculator, about PRAESENSA power calculator. So now we have made the decision to make a transition from the Excel-based tool into web-based tool, where then the web-based tool will be as much detailed as the Excel tool. In addition to that, it would allow to import all the bill of material from the system configuration utility, or to enter all the information manually, or to combine. So import the generated bill of material, and in addition to that, modify additional entries like call stations and additional accessories which would be used in the system in that power online power calculation tool, and then get a precise result of the required power parameters. Also, the results could be exported, stored in an archive, and that exported data could be then re-imported back into the tool and then modified again. All would be in the comma separated value format. So when it is exported, it is not intended to be modified. It's simply as an archive, as a backup of the data, which can be re-inputted at any moment back into the online tool, and then modified, and then printed out in a form of report. And also but again, the data set could be just stored again back for archiving. The point is that the tool itself, it does not store, it cannot store any user relevant information. It simply is a tool which you borrow from the web, so to say. You modify your data, but you keep your data with you. Nothing whatsoever is ever stored on the Bosch server anywhere. So your data is not processed. So everything when you load the tool into your web browser, the tool is in your web browser on your PC. You do the processing so that everything happens on your PC. Nothing is obtained and sent back to Bosch. Bosch simply provides you a mean to process your data and to get the best result out of it.